one sentence.
Okay, guys. So, multiplying and dividing fractions. Get your warm-up packets out.
Yeah, you're
Keep
cool,
going.
Bo. Could be sitting here.
How do you do it? You gotta start it again.
Actually, there is. Okay, perfect. That's an proportional relationship. So if it were 2/3 equals 9/x and cross multiply, but you're just multiplying.
So all you do is.
Parker, can you just sheet?
Yeah.
Lizzie, you go to the bathroom and finish the one.
Yes. Okay, guys. So, thinking back to middle school where it seemed like all you just did was fractions, fractions, fractions. How do we multiply fractions? Yep, we can just multiply straight across. And we also have a shortcut that I really want you guys getting used to doing because we're going to be using it moving forward when we are multiplying and dividing rational expressions. Okay, and that is canceling out. All right. So how many of you guys said, well, 2 goes into 2 once and into 14 7 times? Anybody do this? Okay. Then we can also cancel out because 3 goes into 3 once, into 9 3 times. So now when I multiply across, I have 3 sevens. Okay. With dividing fractions, how many of you guys are familiar with keep, change, flip? Okay. That's kind of the strategy we're going to be using with dividing fractions. Is that this first fraction stays the same. We change to multiplication and we flip this second one. Okay. So hopefully that's a familiar strategy and how you were taught how to divide fractions. So now essentially I'm multiplying just like I was on my first one. You can do some reducing. 5 goes into 5 once, into 25 5 times. 3 goes into 3 once, into 12 4 times. 1 times 5 is 5. 1 times 4 is 4. Okay, I could rewrite this as a mixed number. So, no. I want you guys now to assess, I can multiply and divide numerical fractions. Okay, so I want you to kind of think about, right, yesterday we were talking about algebraic fractions and just simplifying them. Today we started with how you multiply and divide numerical fractions. What do you think we're doing today? Yeah, we're going to combine the two. So we're going to take algebraic fractions and we're going to be multiplying and dividing them. So we're going to be taking x plus 3 over x minus 5 times x minus 5 over x plus 2. Okay, so it's an easy one, but we're going to get more and more complicated as we go along. Tomorrow, Mr. Hunt and I are going to be gone. So we have a series of trainings that we are going to be attending through the school year, 6 in total, and we kind of cringed at that, but we're also excited because we're learning new things, but that's almost a week that we are going to be out of class just for these trainings. So we wish we could just give you guys like a free day and like a work day, but really, in the grand scheme of things, we cannot. So I put together some videos. I know, not very exciting, but some videos on adding and subtracting rational expressions. So you guys are going to bring your headphones tomorrow, and you'll be doing basically just kind of like learning online via videos for tomorrow. Okay, so I know a lot of you usually always have these on you no matter what. So if you don't usually have them, please bring them to class tomorrow. Okay. Any questions on that? All right. So like I said, tomorrow is adding and subtracting rational expressions. Today is multiplying and dividing rational expressions. So if you want to get your notebook set up for multiplying and dividing rational expressions, we will do some examples. And today is kind of a sit and get day where we just kind of go through example after example after example. This is one of those concepts that it's really easy to make some small mistakes, and that like discovery piece of working with the group, we figured would be the best fit. So that's why we kind of are squeezing it in as a direct instruction day. So we know how to multiply and divide fractions. That is what we just did in our warm-up. But what if these fractions have variables in them? Okay. In other words, rational expressions. Is the process the same? Today we're going to be learning how to multiply and divide rational expressions. So to start, let's just review what we did yesterday. So in your notebooks, write down problem 385, which is 3x squared plus 11x minus 4 over 2x squared plus 11x plus 12. So hopefully if you took away anything from yesterday, it was that we can't reduce or cancel things out unless our numerator and our denominator are written as products. Okay. Right now I have addition in my numerator and addition in my denominator, so nothing is being multiplied. So the process that we use to rewrite those as a product is factoring and box and diamond. So we need a box and diamond to factor 3x squared plus 11x minus 4 and 2x squared plus 11x plus 12 in our denominator. So you guys are going to get a lot of factoring practice in this chapter here. So I'm rewriting this numerator so that it is a product. Taking 3x squared and negative 4, 11x, and multiply up to get negative 12x squared. So now I'm wondering, what multiplies to negative 12 adds to 11? $12 and negative 1, thank you. Okay, so then I'm just going to go ahead and fill these in. So now my numerator can be rewritten as 3x minus 1 times x plus 4. I need to use the same process for my denominator. So I'm going to take 2x squared, 12, 11x, multiplying up, 24x squared. What multiplies to 24x squared and adds to 11? Do I need to slow down? I believe you. Right. So now I I factored it, so I can rewrite 2x squared plus 11x plus 12 as a product of 2x plus 3 times x plus 4. Good. Now I'm hearing some people say we can cancel out
Cancel right out.
x plus 4 and x plus 4. Anything divided by itself is 1, so it's really like I'm taking 3x minus 1 over 2x plus 3 times 1. 3x minus 1 over 2x plus 3. Now you always, 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 no matter where you get, you want to be checking to see if you can factor further. Because if you can factor further, there's a possibility that you can get even simpler. So you're asking yourself, can I factor 3x minus 1? Is there something that goes into 3x and 1? No. Can I factor 2x plus 3? No. Okay, so we are as simple as we can get. So that is a review from yesterday. Okay. We have to have that foundational base to move forward with multiplying and dividing, and then tomorrow adding and subtracting. Okay? So here we go, a pretty simple basic one. We are taking 4x plus 3 over x minus 5 times x minus 5 over x plus 3. Okay, so go ahead and see if you think you know. Okay, because we use that strategy of just multiplying straight across with fractions. Okay, I could rewrite this. Most of you are probably going to save yourself an extra step. So if I were to rewrite this, it would be 4x plus 3 times x minus 5 over x minus 5 times x plus 3. Okay, so now some people are thinking, oh, do I need to expand this out? But how do I want to leave it? Okay, I always want to leave it as a product. Okay, so you don't really ever want to be expanding at this point. If you can leave it factored, leave it as factored. So hopefully you guys just recognize, okay, we could have done this here, but I have an x minus 5 in my numerator and in my denominator. So this would just leave me 4x plus 3 over x plus 3. Now, really common mistake that people say is that that equals 4. How are they getting that? I can maybe reduce that down to 4.
Cancel the 3.
Yeah, they see an x plus 3 and an x plus 3. Okay, so they go, oh, but that would only work if this were written as a product, as 4 times x plus 3 over x plus 3. Then we can use that process. Okay, but because this is not written as a product, okay, these have different values. 4 times x plus 3 and 4x plus 3 are different expressions. So we cannot cancel this out any further. So this is our final answer. Okay, and we could test a point. Okay, or test a value for x to see if it's true, and we find it does not always equal 4. This one, okay, let's not do this one in our notebooks just to save time. But what this would turn into is x plus 2, because I'm dividing, over 9x minus 1 times, changing it to multiplication, 9x minus 1 over 2x plus 1. What's going to happen here, guys?
Why do you only split the right side?
Why do we, it's a really long, complicated process, but I can explain it to you if you want, but yeah, keep, change, flip. That's what I would try and memorize. Keep, change, flip for dividing fractions. Okay, so what would happen if I'm multiplying this? Yep, these would cancel out, and then I would just have x plus 2 over 2x plus 1. Good. All right, this one also save. Okay, this one does reduce, so I want you to see how it can reduce and why it can reduce. Can we rewrite this as 2m plus 3?
If it makes you feel fuzzy.
Yeah. Okay, and people are like, are you going to try and trick us like that on the test? Absolutely not. Okay, so then obviously we would be able to cancel out here 2m plus 3 and 2m plus 3. So our final answer would be 7 plus 4m over 3m minus 2.
How can you put 7 plus 4m over 3m minus 2 if there's a if you have to multiply them first? Because
They cancel out.
they're on separate sides.
So we have. Okay, well, do you agree that if I were to just multiply them right away, it would be 2m plus 3 times 7 plus 4m over 3m minus 2. And then if we rewrite it, 2m plus 3.
Sure.
Okay, because with multiplying fractions, all we do is multiply across. So using that concept of yesterday that, okay, 2m plus 3 over 2m plus 3 is going to be 1. So those cancel.
Are you always gonna give us ones that cancel out?
Probably. Yeah.
Easy.
Does that, are you still confused, Cole? Hello?
That's probably on my side though.
Okay, so we'll keep going and then I'll check in with you at
So
the end
this
of
is
class.
way easier than the adding ones we did yesterday. Whoa.
Okay. So now we're getting a little bit more complex. I have y minus 2 cubed over 3y times y plus 5 over y plus 2 times y minus 2. So take some time. I want you guys to try this one on your own. Think about what does y minus 2 cubed mean?
There's 3
There's 3 of
of them.
these. So I have 3 y minus 2's in my numerator, 1 in my denominator. It's going to happen. So go ahead and try this one on your own. So what is going to reduce or what is going to cancel out? Nick?
Y minus 2.
Yep. So I would have one, I have 1 y minus 2 that cancels out. So if I had y minus 2, y minus 2, y minus 2, one of those would cancel out, so there's really only 2 left. Okay? So that would leave me with y minus 2 squared, because 1 canceled out, times y plus 5 over 3y times y plus 2. Okay, so do I have these written as products? Yes. It is y minus 2 times y minus 2 times y plus 5. Okay, and then my bottom I have 3y times y plus 2. From here, does anything cancel out? Do I have any factors in my numerator and in my denominator? Because if I think about it factor by factor, in my denominator, this is 3 times y plus 2. So I have 3 different factors here. I'm multiplying 3 different things. Okay, do any of those separate factors appear as a separate factor in my numerator? No. So this is as simple as we can get. This one is division. So the first thing I would do is what, Jake? When I divide fractions, what do I do?
Keep, change, flip.
Yep. So there's kind of a lot going on here. All right? A variety of ways you can do it. Okay? So at this point I'm multiplying, so all I want to do is multiply across. I can reduce before I multiply across. Okay? Or I can multiply across and then reduce in the end. So any way you want to approach it is fine. I'm going to kind of show you a very basic way. Okay, so this is 15 times 4 is 60. Then I'd have x cubed y squared. You guys have been so good. Over in my denominator, okay, because we can always multiply our coefficients together. 3 times 10 is 30. I have x squared, which is 2 x's, y times y. So what is going to be able to cancel out here? The x's. I have a y in my numerator, y in my denominator, another y in my numerator, another y in my denominator. Something else can cancel out here.
Well, we can reduce it to 20.
What was that, Nick? Yep, 60 divided by 30. Okay, or 30 goes into 30 once, into 60 twice. So what is left in my numerator is 2 times x. What is left in my denominator is 1. So 2x over 1 is just 2x. Okay, I do have one more example, but let's do one of these on your homework first instead of this one.
Who would have thought that equation just equal 2x?
So now this,
Nobody.
okay, gets a little bit more complicated. All right, but we have 5 minutes left. So, I'm thinking we want to do either 3 or 4 together. So let's go ahead and do 4 together.
Is this
Yeah.
our homework?
So when we do 4 together, this is all your homework. So, and we're doing the most complicated one right now. So it's 6x squared minus x minus 1, 3x squared plus 25x plus 8 times x squared plus 4x minus 32, 2x squared plus 7x minus 4. Okay, so what we want to do is multiply across.
So 6
Okay,
times
but-
8 is 32.
Or what we can do, okay, and we always want everything written as a product. So ultimately what we want, how we want to address this is we need to factor this, 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 and this. So we're going to have to do box and diamond 4 times. You guys want me to give them to you as factors?
Yeah.
I feel like 6x squared minus
Use your
x
smart
minus 1
brains.
doesn't work. Because they have to multiply to negative 1.
Oh, we gotta go.
Alright,
Sorry.
kill that. I'm in here right now if you guys want to go through it, but now I'm nervous because it doesn't matter.
Just look at the answer key, it always helps. Kidding.
Oh, this is why. 2x minus 1 times 3x plus 1.
Have a good night.
See you, Nick.
Nobody's